Hello students. Welcome back to Smart Tricks for Study channel. Today we will see class 12th physics, last minute preparation question to score 50 plus easily for your board exam. Don't skip. If you want PDF copy, just comment or join our Telegram channel using link given in description. Share with your friends and don't forget to subscribe the channel if you not subscribed yet. Let's start with MCQ. Part A. Pick the correct option among the given options for all questions. Each carries 1 marks. Let's start. 1. The electric flux over a closed surface enclosing a charged particle is minus q by 6 epsilon naught. The charge of the particle is. Answer is option C. Minus q by 6. Next. 2. Two capacitors of capacitance C1 and C2, C1 is not equal to C2, are connected in parallel to an external source of potential difference V. The equation which is not applicable for the given combination is, symbols have their usual meanings. Answer is option B. V is equal to V1 plus V2. Next. 3. In case of metals, with increase in temperature. Answer is option A. The conductivity decreases. This is because in metals, when temperature increases, atoms vibrate more, causing more collisions with electrons, so conductivity decreases. Next. 4. A galvanometer can be converted into a voltmeter by connecting. Answer is option D. A high resistance in series with it. Next. 5. In the following table, column 1 is the list of magnetic property and column 2 is the list of an item related to magnetic property. Identify the correct match. Answer is option C. 6. Magnetic flux is. Answer is option B. A scalar, and its SI unit is Weber. Next. 7. The resonance frequency of a series LCR circuit remains constant even if there is any variation in the value or values of. Answer is option D. Resistance R. Next. 8. Electromagnetic waves are produced by. Answer is option C. Accelerated charges. Next. 9. A real object is placed between the pole and principal focus of a concave mirror. The image formed is. Answer is option A. Virtual and magnified. Next. 10. The waves coming from two coherent sources overlap at a point to give maximum intensity. The phase difference between the superposing waves may be. Answer is option B. 6 pi. Next. 11. Identify the correct statement. Answer is option D. Light waves exhibit both diffraction and polarization. Next. 12. In a photoelectric experiment, The graph related to two quantities is a straight line with slope equal to h by e. Then it is a graph of. Answer is option C. Stopping potential versus frequency of incident light. Next. 13. The total energy of an electron revolving in nth orbit of hydrogen atom is the least for. Answer is option B. N is equal to 1. Next. 14. An example for isobars is. Answer is option D. 3H1 and 3He2. Next. 15. When a p-n junction diode is reverse biased. Answer is option A. Both the barrier height and width of depletion region increase. Next. 16. If a body contains n1 protons and n2 electrons, then the net charge of the body is. Answer B. n1 minus n2 into E. Next. 17. The electric potential at a point, due to a point charge, varies with distance from it as. Answer A. 1 by distance. Next. 18. Kirchhoff's junction rule is based on the conservation of. Answer D. Charge. Next. 19. The path traced by a charged particle moving perpendicular to a uniform magnetic field is. Answer A. Circle. Next. 20. Based on the magnetic properties, materials are listed in column 1 and values of magnetic susceptibilities are listed in column 2. Identify the correct match. Answer is B. For diamagnetic, susceptibility is small and negative. For paramagnetic, susceptibility is small and positive. For ferromagnetic, susceptibility is large and positive. Next. 21. A straight conductor of length L is moving with a velocity v in the direction of uniform magnetic field B. The magnitude of induced EMF across the ends of the conductor is. Answer is C. 0. Next. 22. When alternating voltage is applied to a resistor, which of the following statements is wrong? Answer is C. The average power dissipated by the resistor over a complete cycle is 0. Next. 23. Which of the following electromagnetic waves are used to kill germs in water purifiers? Answer is C. Ultraviolet rays. Next. 24. The angle of minimum deviation of a prism depends on. Answer is D. All. That is, it depends on refractive index of the material of the prism, refractive index of surrounding medium, refracting angle of the prism. Next. 25. Image of a real object formed by a simple microscope when the object is placed at a distance less than the one focal length is. Answer is B. Virtual, erect and magnified. Next. 26. Consider the following two statements regarding diffraction of light. Statement 1. We do not easily encounter diffraction effects of light in everyday observation. Statement 2. The wavelength of light is much smaller than the dimensions of most of the obstacles. Choose the correct option from the following. Answer is A. Both the statements are correct and statement 2 is the correct explanation for statement 1. Next. 27. The process of emission of electrons from a metal surface by applying high electric field is called. Answer is C. Field emission. Next. 28. Let K be the kinetic energy, U be the potential energy and E be the total energy of electron revolving around the nucleus in hydrogen atom, then which of the following is correct? Answer is B. K greater than 0, U lesser than 0, E lesser than 0. Next. 29. Among the following, which set of nuclei are isotones? Answer is C. 6C14 and 7N14. Next. Carbon, silicon and germanium have 4 valence electrons each. These are characterized by valence and conduction bands separated by energy band gap respectively equal to energy gap of carbon, to energy gap of silicon and to energy gap of germanium. Which of the following comparison of energy band gaps is correct? Answer is C. Next. 31. The electrostatic force between a pair of unlike and like charges respectively are. Answer is B. Attractive, repulsive. Next. 32. The electric potential at the surface of a conducting charged spherical shell of radius 10 cm is 20 V. The electric potential at the center of the shell is. Answer is C. 20 volt. Next. 33. As the temperature increases, the resistivity of. Answer is A. Metals increases and semiconductors decreases. Next. 34. A charged particle moving in a circular path in a uniform magnetic field. Then choose the wrong statement among the following. Answer is D. Frequency of revolution varies directly with the kinetic energy of charge. Next. 35. A magnetic dipole of magnetic moment m is placed in a uniform magnetic field B, such that the angle between M and B is theta. If the magnetic dipole is in stable equilibrium position, then. Answer is A. Theta is equal to 0 degree. Next. 36. The dimensions of inductance is. Answer is A. M, L square, T to the power minus 2, A to the power minus 2. Next. 37. Different devices connected to an AC source are listed in the first column and different phase relations of electric current with the voltage are listed in the second column. Choose the correct match. Answer is C. Next. 38. Expression for displacement current is given by. Answer is A. ID is equal to epsilon naught d phi by dt. Next. 39. The objective lens of a refracting telescope is a dash, and the magnifying power of the telescope for normal adjustment is dash. Answer is C. Convex lens of large aperture, M is equal to F naught by Fe. Next. 40. Among the given two statements. Statement 1. Wavefront is the surface of constant phase. Statement 2. When a plane wavefront is passed through a thin prism, it emerges out as a spherical wavefront. Answer is C. 1 is correct but 2 is wrong. Next. 41. In photoelectric effect experiment, the graph of a physical quantity, y, vs a physical quantity, x, is a straight line passing through origin. Then. Answer is D. Y is photoelectric current and x is intensity of incident radiation. Next. 42. An alpha particle, a proton, an electron and a neutron are moving with same velocity. Then the particle having longest de Broglie wavelength is. Answer is B. Electron. Next. 43. Rutherford's nuclear model of atom fails to explain. Answer is D. Origin of line spectra of hydrogen atom. Next. 44. Nuclear binding energy per nucleon is. Answer is C. Less for both light and heavy nuclei. Next. 45. If Ne and Nh are the number of free electrons and holes respectively, then in case of an intrinsic semiconductor. Answer is A. Ne is equal to Nh. Now let's study some fill-in-the-blanks questions. Fill in the blanks by choosing the appropriate answer given in the bracket for all the following questions. Each carries 1 marks. 1. An example for dimensionless quantity is dash. Answer is magnetic susceptibility. Next. 2. A current carrying coil stores energy in the form of dash. Answer is magnetic field. Next. 3. The power factor of a series LCR circuit at resonance is dash. Answer is equal to unity. Next. 4. The principle of optical fiber is dash. Answer is total internal reflection. Next. 5. The bending of light around the corners and entering into geometrical shadow region is called dash. Answer is diffraction. Next. 6. The net magnetic moment acquired per unit volume of a sample is called dash. Answer is magnetization. Next. 7. Lenz's law gives the dash of the induced EMF. Answer is polarity. Next. 8. The phase difference between voltage and current in a pure resistive AC circuit is dash. Answer is 0 degree. Next. 9. If the angle of incidence for a ray of light in denser medium is equal to critical angle, then the angle of refraction in rarer medium is equal to dash. Answer is 90 degree. Next. 10. The minimum energy required by an electron to escape from the metal surface is called dash. Answer is work function. Next. 11. A current carrying dash is equivalent to a bar magnet. Answer is solenoid. Next. 12. The device which converts mechanical energy into electrical energy is dash. Answer is AC generator. Next. 13. The device that varies alternating voltage is called dash. Answer is transformer. Next. 14. The phenomenon of light which confirms the transverse nature of light waves is dash. Answer is polarization. Next. 15. During photoelectric emission, the number of photoelectrons emitted per second is directly proportional to the dash of incident light. Answer is intensity. Next. 2 marks questions. Let's see one by one. 1. Define electric flux through an area element. Mention its SI unit. 2. Sketch the electric field lines for A. A positive point charge and B. An electric dipole. 3. Define electric field at a point. What is meant by source charge? 4. State and explain Coulomb's law of electrostatics. 5. Write Coulomb's law in vector notation and explain the terms. 6. Explain the principle of superposition to calculate the force between multiple charges. 7. Mention the expression for the electric field due to a point charge placed in vacuum. 8. Write the expression for the electric field due to a system of charges and explain it. 9. Mention any 2 properties of electric field lines. 10. Write the expression for the torque acting on an electric dipole placed in a uniform electric field and explain the terms in it. 11. Define linear density of charge, or surface density of charge, or volume density of charge and mention its SI unit. 12. How does the electric field and electric potential vary with distance from a point charge? 13. How does the electric potential at a point due to an electric dipole vary with distance measured from its center? Compare the same for a point charge. 14. Using superposition principle, write the expression for electric potential at a point due to a system of charges. 15. What is meant by equipotential surface? Draw equipotential surfaces for an electric dipole. 16. What are polar molecules? Give an example. 17. The electrostatic potential energy of a system of 2 like charges is positive. Explain. 18. Explain why electric field inside a conductor is always 0. 19. Define capacitance of a capacitor. What is SI unit? 20. What are polar and nonpolar dielectrics? Give examples. 21. State and explain Ohm's law. 22. Write any 2 limitations of Ohm's law. 23. Name the factors on which the resistance of the conductor depends upon. 24. What are ohmic and non-ohmic device? Give an example for each. 25. State and explain Kirchhoff's current law. 26. State Kirchhoff's voltage law. 27. Name the mobile charge carriers in metals. Write the expression for mobility in terms of average collision time, relaxation time, for charge carriers. 28. When the force on a charge moving in a magnetic field is A. Maximum. B. Minimum. 29. Mention the expression for Lorentz force and explain the terms. 30. Give the vector form of Biot-Savart's law and explain the terms. 31. Write any two properties of magnetic field lines. 32. Define magnetic flux and mention express for it. 33. State and explain Gauss's law of magnetism. 34. Mention the two factors on which self-inductance of a solenoid depends. 35. What is the nature of the force between two parallel conductors carrying currents in the A. in same direction and B. in opposite direction? 36. What are diamagnetic materials? Give one example. 37. What are paramagnetic material? Give one example. 38. What are ferromagnetic material? Give one example. 39. State and explain Faraday's law of induction. 40. What are eddy currents? Give one use of it. 41. What is meant by self-inductance and mutual inductance? 42. Calculate the magnetic energy stored in a coil of self-inductance 0.05 Henry carrying a current of 0.2 ampere. 43. What is AC generator? What is its working principle? 44. What is displacement current? Write the mathematical form of Ampere-Maxwell law. 45. Distinguish between inductive reactance and capacitive reactant. 46. List any two uses of infrared rays, or UV rays, or microwaves. 47. Name the electromagnetic waves used in 1. The radar systems of aircraft. 2. The laser-assisted eye surgery, LASIK. 48. Write any four properties of electromagnetic wave. 49. Write an expression for velocity of light in terms of permittivity and permeability. 50. State Huygens principle. 51. Mention the conditions for diffraction minima and maxima. 52. What is diffraction of light? Give an example. 53. Name the wavefront obtained when a plane wave passed through. 1. A thin convex lens. 2. Thin prism. 54. Define impact parameter. What is the angle of scattering for minimum impact parameter? 55. Mention the expression for de Broglie wavelength in terms of kinetic energy of the particle and explain the symbols. 56. Mention Einstein's photoelectric equation and explain the symbols. 57. Mention the expression for de Broglie wavelength of a particle and explain the symbols. 58. Explain how stopping potential varies with intensity of incident radiation. 59. What is photoelectric work function? Mention expression for it. 60. Give any two limitations of Bohr's atomic model. 61. Write the expression for the radius of n at orbit. Give the meaning of symbols used. 62. Give the expression for velocity of an electron in the n at orbit. Give the meaning of symbols used. 63. The radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 to the power minus 11 meters. Determine the radius of the n is equal to orbit. 64. What are isotopes? Give one example. 65. What are isobar? Give one example. 66. What are isotones? Give one example. 67. Derive the relation between mass number and radius of the nucleus. 68. Mention Einstein's mass-energy relation and explain the symbols. 69. What is alpha decay? Give an example. 70. What is beta decay? Give an example. 71. What is gamma decay? Explain with example. 72. What is nuclear fission? Give an example. 73. What is nuclear fission? Give an example. 74. Define half-life and mean life of a radioactive nucleus. 75. List out two differences between p-type and n-type semiconductors. 76. Give any two differences between intrinsic and extrinsic semiconductors. 77. Mention any two differences between half-wave and full-wave rectifiers. 78. What is photodiode? Mention its one use. 79. Draw a labeled diagram of a full-wave rectifier. Draw the input and output waveforms. 80. What happens to the width of the depletion layer of a p-n junction when it is 1. Forward biased. 2. Reverse biased. 81. Draw a labeled diagram of a half-wave rectifier. Draw the input and output waveforms. 82. Name one impurity each, which when added to pure silicon produces 1. N-type and 2. P-type semiconductor. 83. Explain why a photodiode is usually operated under reverse bias. 84. Draw the circuit symbol of a Zener diode. 85. Mention the necessary conditions for doping. 86. Name the majority and minority charge carriers in p-type semiconductors. 87. Name the majority and minority charge carriers in n-type semiconductors. 88. What is an equipotential surface? Draw equipotential surfaces for a point charge. 89. When is the force on a charged particle moving in a uniform magnetic field? A. Maximum and B. 0. 90. Name the electromagnetic waves produced by A. Accelerated motion of charges in conducting wires, and B. Hot bodies and molecules. 91. The magnetic flux linked with a coil changes from 5 into 10 to the power minus 3 Weber to 3 into 10 to the power minus 3 Weber in 0.01 second. Calculate the magnitude of the induced EMF in the coil. Next we look into some important 3 marks questions from Part C. 1. Define linear charge density. Mention the expression for electric field at a point due to an infinite line of charge and explain the terms. 2. Give Coulomb's law in vector form and explain the terms. Define SI unit of charge. 3. Derive an expression for torque acting on an electric dipole placed in a uniform electric field. 4. What is a capacitor? Mention any two factors on which capacitance of a parallel plate capacitor depends. 5. Mention any 3 important results regarding electrostatics of conductors. 6. Obtain the expression for equivalent capacitance of 2 capacitors connected in series. 7. Explain the conversion of galvanometer into an ammeter using relevant circuit diagram and expression. 8. What is Lorentz force? Write the expression representing this force and explain the terms. 9. In a chamber, a uniform magnetic field of 6.5 into 10 to the power minus 4 Tesla is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power 6 meter per second normal to the field. Determine the radius of the circular orbit. Given, E is equal to 1.6 into 10 to the power minus 19 coulomb and mass of electron is equal to 9.1 into 10 to the power minus 31 kilograms. 10. State and explain Gauss's law in magnetism. Give its significance. 11. Write any three differences between diamagnetic and paramagnetic materials. 12. Mention any three properties of magnetic field lines. 13. Derive the expression for the motional EMF induced in a conducting rod moving perpendicular to a uniform magnetic field. 14. Derive the expression for the magnetic energy stored in a coil, U is equal to 1 by 2, L I square. 15. Describe the coil and bar magnet experiment to demonstrate the phenomenon of electromagnetic induction. 16. Give the Cartesian sign convention used to measure distances and heights in spherical mirrors. 17. Show that the focal length of spherical mirror is equal to half of its radius of curvature. 18. Write any three properties of photon. 19. Draw the ray diagram for the formation of image by a compound microscope. Write the expression for linear magnification produced by the objective of compound microscope in terms of its tube length. 20. What are matter waves? Explain the de Broglie hypothesis of matter waves. 21. The work function of cesium is 2.14 eV. Calculate the threshold frequency for cesium. 22. Give the Cartesian sign convention used to measure distances and heights in spherical mirrors. 23. Calculate the binding energy of an alpha particle in MeV from the following data. Mass of alpha particle is equal to 4.00260 U, mass of neutron is equal to 1.00866 U, mass of proton is equal to 1.00782 U. 24. Mention three features of nuclear force. 25. Differentiate between nuclear fission and nuclear fusion. 26. Using Ampere's circuital law, obtain the expression for magnetic field at a point due to an infinitely long straight conductor carrying current. 27. Write the three basic properties of electric charges. 28. Derive the expression for energy stored in a current-carrying inductor. 29. Show that the radius of curvature of a spherical mirror is equal to twice its focal length. 30. Mention any three experimental results of photoelectric effect. 31. Calculate the binding energy of an alpha particle, that is helium, in MeV from the following data. Mass of alpha particle is equal to 4.00260, mass of neutron is equal to 1.008662, mass of proton is equal to 1.007825. Next we will see 5 marks questions with problems. Practice these questions. This helps to score 50 plus in your board exam.